because we're going to move away from tops and chops, and we're going to look at SOPs and geometry. So in the same way that tops are texture operators, chops are channel operators, SOPs stand for shape operators. Let's go to our good old derivative SOPs. Surface operators, not shapes. Also known as SOP, are operators that can generate, import, modify, and combine 3D surfaces. Surface types are polygon, curves, NURBS, surfaces. Basically 3D shapes. Now, it takes a while to get your head around, but SOPs are not geometry in Touchdesigner's usable world space when you bring them into the blue form. To use SOPs that come in, we need to add them to a geometry comp. And then, when they go into that geometry comp, they become something that's usable in Touchdesigner's world geometry space, so that we can access, manipulate it, and use it for things like creating a 3D render. Each layer within your project, so for example, the base layer and then my project 1 layer, all have different 3D geometry worlds. But let's have a look how to get started. So I'm gonna, with a SOP, we can, the same as our tops, but in a 3D variety, can create, manipulate, and import 3D objects from anywhere. So it accepts, we can use, you could use something like a file in to open a geometry file, like an OBJ, or we can create geometry here in Touchdesigner using things like the built-in shapes such as box, circle, rectangle, wherever that is, over here, rectangle, tube, torus. All of these are primitive 3D shapes that you can bring in and then manipulate any way you want. One example would be something like bringing in a sphere. We have a simple 3D object at the moment as a mesh. You can change it to a polygon, or a polygon. And something that we can then decimate. So if I was to do display option, so I'm going to right click it and show. Right, okay, none of these are really giving me the effect I want. But we have a 3D object that we can then control. So the more frequency I add, the higher quality the circle it's going to make. And we can then manipulate and use that in certain different ways. So what am I trying to create here? Let's take my sphere and add a noise. So straight away we have a 3D shape that we are able to edit and manipulate in real time. Transform in shape uses absolute time, a Python reference to the absolute timeline within the computer. So apps time is going to refer to the amount of time that Touchdesigner has been open and running. You could also do something like me.time.frame. It's divided by 1000, and that's going to reference the current frame inside the timeline. So you can see that it's, when it gets up to 600, it will reset back to 1. But using something like abs time.seconds gives us a constantly changing number that won't snap back and reset like we saw there with the other timeline. But we'll come to programmatic references in our Python lesson later down the road. Okay, so I have a shape that is doing something. What can I actually do with this? Well, the first thing we normally want to do is add something like a transform, so we can move it, scale it, maybe rotate it slightly so we get a better view. But ultimately we want to give it a color. So like with 3D objects, we are going to add a material. And as shocking as it may be, materials are applied via the material operator. So in the same way that tops and chops work hand in hand together, SOPs and mats also work hand in hand together. Materials come in a bunch of shapes and sizes. We have GLSL, where we can write our own. Wireframe, where you can see that it takes away the actual polygonal surface and just gives us the vertex of the shape, which can be used to a really cool effect, but we'll duplicate that in a second. But things, you can apply a constant, which gives a globally equally illuminated shape that does not take any interference from light. So you can see you get a very flat color, you can't see the shapes anymore. Or we can use something like a Phong, which is going to give us a more realistically shaded 3D shape. So you can see we still can't quite see it because it's taking from a global light somewhere in the SOP world, but we can use this to accept parameters from our real world light when we move into the world geometry space. But for now, I'm just going to leave the Phong on that shape. I'm going to right click at the end of my material, and instead of adding a SOP, I'm actually going to use a special function built into Touchdesigner. I'm going to go to the comp window and add this SOP to a geometry. And although we know from our past lessons that we can't link any type that is not the same, so a purple must link to a purple, a green to a green, and a blue to a blue, by doing right click comp geometry, it's actually going to make us geometry that has a special setup inside to accept our input. So this effectively meets a container, and in that container it puts a SOP in that we're allowed to connect to. Because if you were to create a normal geometry, you see it always defaults to have a torus inside of it, but that's no use when we want our own shape. So right click on the outlet and accept a geometry. Now, it may not seem like anything has changed, but the simple act of including this geometry container has taken our simple 3D shape from being its own 3D geometry in its own 3D space to putting it into Touchdesigner's world space, which means that we can then manipulate and use this to create way more effects than we originally could. So I am going to create a constant top and make it a nice color. I'm going to apply that to my Phong under the color map. Now it's simply going to give my shape a orange hue while still keeping its light accepting parameters. I'm then going to add a comp camera and a comp light. Now, by adding these, we are altering the Touchdesigner world space. I'm going to make my shape a bit smaller here so we can see it back to its original 1 scale. So everything that's on the screen now means that we've made a 3D geometry that we are manipulating using time in our noise, and then we're applying a color to it with a Phong. So we're applying a texture that can accept light, but it exists only inside these nodes. Second, we do this and add it to the geometry container, add a camera and add a light, means that we've introduced this shape into a world space where we can manipulate it from a viewing perspective. For example, if I was to move my light, let's see, if I was to change my light and make it, it's not going to do anything. Alright, okay, I realize what's happening. So the final piece of the puzzle we need is we have world geometry that we can now manipulate and look at through a camera, but we need somewhere to capture this camera. So we introduce a special render top. And as you can see by the description, it's used to render all 3D scenes in Touchdesigner. You give a camera object and a geometry object at a minimum, and we have both of these. So let's give it a render. An instant we'll see that it automatically links all the geometry, the camera, and the light into it, indicated by it defaults to camera 1, it accepts all geometry and all light. This star just represents a wild card, so it'll accept all. I could name my geometry, so Geo 1 will link it, but if I type Geo2, you'll see that we don't see any geometry because this render is not capturing it. Okay, so now I've got my geometry. So now if I move my light, yeah, there we go. So we can see that thanks to that Phong, our object is accepting input from light. I'm going to go back over here and turn off transparency because we don't need that. Yeah, so now I have a shape that is accepting a hit from light. If I was to change this to a constant material, you'd see the difference between the two. So whether I have the light or not makes no difference to the scene because it renders a purely flat shape, which can be really nice for an effect depending on what you are trying to achieve. It's a very good way of achieving transparency if you introduce a level of alpha, so turn down so it's half opaque. And then in the Common tab, turn on blending transparency. This means that Touchdesigner's renderer will attempt to work out what should be behind the shape. And you can see we start getting all these weird sort of overlaps occurring, and that's because we're basically seeing through the shape. As well as using a material top, you can also directly apply materials to geometry. The difference in why I would use them sort of you'll come up in varying times, but it means that you can use a single pipeline of SOPs to feed multiple different instances of geometry in the world space. So now, for example, if I duplicate our geometry, so we have a second instance of the same shape, and then parent them one to another, so that if I was to move one, they both move. If I unlink them, oh, that's way too much. So now you can see that I can, if I move this, you can see it creates two different shapes. Whereas if I link them, it means it's both shapes are moving in the exact relation to each other. So now this will mirror exactly what that does. And that's what this top to bottom grey link here that we've not seen before does. That acts as a parent between the two. So now I've got my shape. What I'm going to do is I'm going to apply a different texture to this one. I'm going to go back to that wireframe we originally looked at. So now we're starting to get a really cool effect built up with very little work going into it. Be careful manipulating your camera because any changes you make to it in the viewer are going to affect the actual view in the camera. So now if I look, you can see it has a bunch of strange values. I'm going to reset this. And the best way to manipulate or look at geometry in Touchdesigner is to split our window again, like we did in our top video to view the panel. I'm going to split it into 3, and in the top one I'm going to drop down and do Geometry Viewer. Make sure my project 1 is selected and then right click Home All. And what this is going to do, this is going to load the world geometry space for this project level we're on. So basically anything, these are all being shown in this window. I can go through and individually select them all, so you can see I can pick this geometry and it turns green. I can pick the other geometry and it also turns green. It's underneath this one, however. I can pick my camera and it turns green. And I also pick my light and it turns green. So this is a great way to view your geometry without having to worry about what you're actually seeing. Another really good tool is to also reuse the example we learned before. So I'm going to introduce a null. I'm going to call it output. I'm going to come back up one level in my scene, and in my master container, so my project 1, I'm going to change its background top to be output. Yeah, so there you go. So it will adopt the output of your render node as its display, and it means that I can change this to be panel, and I can see both a camera's eye view and a 3D world view of everything in my scene. Now, what happens if we could make this a bit more exciting? So the first thing is I'm going to increase the weight of my wireframe, and I'm also going to turn on transparency and blending for it. Turn the transparency down a bit. So there we go, we've got a nice cool effect. Maybe play with the color slightly if you don't like that. There we go, a nice purple, that looks good. Just to confuse everyone when I talk about purple tops. So now I have what my camera sees, I have my full 3D world. So if I was to move my camera on the left and right, you can see the panel at the bottom shows the camera moving to the left and right. And then in our 3D geometry scene, I can actually see the camera highlighted and panning left and right. In the last episode, we started playing about with chops, things like LFOs, that allowed us to animate parameters of the tops we were working with. Now, Touchdesigner, amazingly, is super dynamic and can handle us exporting chop data into something like geometry node, SOP node, even into render parameters. There's nowhere that if you have a parameter that has an open field, you can't send data. So let's do some crazy animations in both the animation of our shape as well as the animation of our camera. So the first thing I'm going to do is I'm going to make this a ramp. So I want to make a beautiful effect where my camera pans around this shape and gets us a load of weird angles. Now to do that, if I was to just rotate my camera, you can see it's going to rotate on its own pivot point. If I home on the selected and then rotate it, you'll see it's going to rotate on this point of the camera, which is its lens or its origin. So what we can do is, if we leave our shape on the origin where it is now, so our sphere is on 0, 0, 0, our noise is on 0, 0, 0, and our transform is on 0, 0, 0, which means that our shape is still on 0, 0, 0 within our 3D world, and you can see that by it's at the intersection of the X, Y, and Z lines represented by the blue, green, and red here. So now, if I treat my camera and tell it to move its pivot point from the front of its lens to the center of the scene, I should be able to rotate around the middle of it. I'm going to do that by adjusting the pivot point to the negative of what my current translation is. Now, I could just type -5, but I'm self-hating, so I'm going to use it programmatically, and I'm going to tell it to reference itself. And to do that, I'm going to look at what my parameter name is. It's tx. And I'm going to say me to reference myself, as in the camera. I'm going to tell it to go and get a parameter value, and I'm going to say tx. And if I now push enter and drop down this menu, you'll see that it changes from being the constant gray value to the expression blue one. So Touchdesigner automatically recognizes that I put a piece of code in there and then goes and does it. It goes and gets the reference. So the same way that when we linked chop, you can see that it turned blue and it gives us the reference. But I made the mistake and I typed tx when I actually wanted to type zz. So 5 and 5. So now if I rotated my camera, it's actually still going to be incorrect, but it's good for an example. So my camera's offset is now 5 from its current pivot point. So my camera is now rotating around this point rather than this point. So I actually need to negate the current movement. So my camera has translated 5 back, and its pivot point was then moved 5 back again. So now, if you imagine a big long bar connecting here like a selfie stick, my camera is now rotating around 0, 0, 0. So if I was to move it, if I do a top-down view, it's home all, and then top-down. So now if I rotate my camera, you can see that it moves around the z-axis, and my panel on the bottom gives us an update of its movement. So let's set that back to 0. And I'm going to copy the same programmatic code. Oh, I just deleted something. Okay, I'm going to copy the same code, so Control C, Control V, Control V, and change these to mimic their representative values. So TX mimics PX represents TX, PY represents TY, etc. Just so now that if I was to move my camera, its pivot point is always going to be the dead center of the scene. And we'll come back to that later and why we're doing that. Okay, so now my pivot point's updated. And as I showed, if I rotate my camera around any of the axis, it is going to correctly update its position. So for example, the top, or up and down. Wrong one, up and down. And again, just to refresh you, when I hover over value, I'm just pushing my middle mouse button to bring up the quick parameter menu, and then I keep holding mouse button, move my mouse up or down, and then left and right, all the while holding middle mouse. So, without going into too much detail of like standard grade maths, a circle has 360 degrees in it, and I want to move my camera all the way around this sphere in a second. So I'm going to insert a math, change its range from 0 to 1 to 0 to 360, and then I'm going to attach this parameter into my rotation with a relative reference. So now, if I go back to a perspective view, zoom out a bit, you can see my camera spinning around it. Might be spinning a bit fast, but the idea is there. So let's slow down the frequency of our LFO. And frequency works in terms of fractions of a second. So when this is 1, it's going to rotate a full time every second in the timeline, so every 60 frames. 0.2 means it's going to run 0.2 divided by 60, other way around, 60 divided by 0.2. So it's going to take 300 frames for it to move all the way around. 300 divided by 60 is 5. It's going to take 5 seconds for my object to move all the way around. Now you can see we're starting to get a really cool effect based on, again, in our camera viewpoint. Let's see if we can adjust our rotation slightly. There we go. So I added a little bit of Z rotation to it, which now means that our camera is on this slightly altered 45-degree axis. Again, because our pivot point has been adjusted, it's still going to keep in line with it. But let's use what we learned in the last lesson to add a button. Or let's do a slider instead, so we never actually used one. So a slider works the same as a button. You can see it's added it down here. I'm going to make it slightly bigger and slightly taller and move it up slightly. So if I scroll in, add a null. A slider gives us a value between 0 and 1. The same way a button does, but it's a variable range. If you haven't been able to work out, or you're not comfortable with using the panel window down the bottom right hand here, you can use any buttons or objects and even reference your shapes by using the Activate Viewer button on all of them. And that was how I quickly linked my chop here. I activated the viewer, selected it, and dragged it. We can do the same with a slider, so I can activate it and I can update the value inside my network without having to have a perform mode, even though it would still work the same if I go into perform mode by pushing F1. Okay, so a slider. And I want to use the slider to make my circle super crazy. And one of the good ways to do that is by either altering the seed of your noise slightly, changing the roughness, maybe that won't work because of how low our sphere is. You can see it's almost like a perfect sphere there. But I think what I'm actually going to do is I'm going to change the frequency of my sphere. So it goes from being this super sharp, low poly shape up to this amazing sort of complex, almost biological form. And to do that, I need to go change the frequency of my shape between 0 and 1. Now, this is coming out between 0 and 1, and I need it between 1 and 10, excuse me. So the simplest option for that would be null into a math. And then I'm going to just do range. And instead of 0, 1, I'm going to do 0 and 10. Connect that up. So activate my viewer, drag it in. Boom, there we go, look at that. Now, the problem we have here is our slider gives floating values, but the frequency of the sphere can only ever be a solid number. So we get this jumping effect. But for now, I think that's okay. There's not really a way we could solve it, so we're just going to have to deal with it. But I really like that effect. When it gets a bit complicated, let's turn down the thickness of our wireframe. You can really see the difference if you go back to your colored constant geometry and turn off blending, how flat and sort of essentially boring it begins to look, purely because of the shape being non-transparent. So turn back on transparency and it gives us this amazing deep look. But I think I'm going to reintroduce my Phong to the material, and I'm going to turn on transparency again. Make sure my alpha is up. Oh, I just clicked a help button, give it a second. In my RG, make sure my colors are good. Yeah, so, oh, yeah, constant map, color map. Okay, so the problem we're not seeing anything is just because the light in my scene isn't properly illuminating the shape. Where is the light currently? I've probably done something super silly that means that it's not picking up color properly. Oh, there you go. It's because I turned off my light in my render. So turn it back on. Now you can see that although our light isn't properly illuminating, oh, we are getting a slight bit of light on it on one side here. So I'm going to stop my camera from rotating at the moment by going into its parameters and switching it back to constant mode. I'm going to home all so I see the view it's seeing. I'm going to reset my light parameter as well. So now my camera and my light are in the same place, but let's make the light a bit more exciting. So in light mode, I'm going to go in and I'm going to change it from a point light to be a cone light. And instantly, the reason the geometry viewer is so helpful is because it explains what this is doing. And it went from being essentially a light bulb without a cap to a light bulb with a very direct cone of focus. A cone that we can make wider and shallower, and then increase what is called the delta. So basically the feathering on the edge of the light. So if I make it super tight and turn my delta all the way down, you see it get pin sharp. Turn up the delta and it starts to roll off. So if we were to look at the help for light by clicking this question mark here, it will tell us that go down to the light page, delta is in degrees representing outside the cone, which light intensity drops from its maximum to 0. Basically, it's the roll off of the light. It's the feather of the shape. So I'm going to make my cone a bit bigger and make my delta smaller so it blurs out slightly. There we go. That's probably a nice medium. So what we have now is our shape. Our light is illuminating the shape directly on from the same perspective as the camera. So I could parent the two directly and remove the translation from my light. So now, if I let my camera rotate again by going into the parameters and re-clicking expression, what's going to happen is my light is automatically going to follow the path of my camera. And you can see the child-parent inheritance via that I've got my camera selected, yet my light is yellow in the geometry viewer because it's saying, well, this is a child of the object you have selected. If I was to select the light alone, it goes green, but the camera stays grey. So the geometry is a great way to understand what you've got happening in your world. So what we have is a bunch of a light following a camera, but it's not quite dynamic enough in the shape. It's basically looking like it's flat onto a circle rather than showing us the depth of the shape coming towards it. So in light and in shadow, I'm going to turn shadows on. I'm probably going to go hard matte, a little better. And let's make a new piece of geometry called a box, and it's exactly as it sounds. So in that box, I'm going to add it to a transform, and that transform I'm going to give a geometry. So that is the process for making shapes. Quick and simple as that. The 3D SOP you want, transform so you can configure it and control it, and then put it into a geometry so you can see it in the world space. And you can see that we can see this square inside our rectangle, or inside our deformed circle. It's just not very visible at the moment because it's not big enough. So I'm going to change the scale of my shape. I'm going to move out a bit. And so my goal here is I'm actually trying to make my cube encapsulate my entire scene. So let me put on a blank constant to that. So what I'm making sure is that my camera doesn't pass outside my cube at too many different places. So I think the best option for that is going to be to no, we don't want to partner that. That was a mistake. Yeah, let's just make our shape slightly bigger. There we go. So now, if I introduce a phone, introduce a phone, material, turn on transparency. I'm actually going to add a second camera to my scene just so I can have a look at something here. And I'm going to bring this one back. So there we go. It's actually really hard to visualize it from our camera, but what I was doing was, let's make this view slightly bigger. So change that to 90. So our camera is viewing our shape inside our sphere now. So I have one that's directly looking at it, not this one. If I was to so this is our main camera that is rotating around the shape, but this is a second camera that is looking directly into the object. So if I connect that to my output instead, you can see that we are able to cast a proper shadow with the shape as it rotates around using that light that we just set up. And you can also see the nice effect it creates on the fractals as it moves around, that as the back sides are occluded by the light, that it's not able to project the color onto. It's something that I was trying to represent, but I couldn't quite show you with the way that we were building it, just due to the way that the camera and light are in the same place. Now that I think about it, if I just done something as simple as offset the light slightly versus the camera, or offset the camera versus the light, we should have been able to see the difference it was creating. I really like the black on black effect actually with the white outline. So the reason that we can see the wireframe even when there's no light hitting it is purely because a wireframe is a constant structure. So the same way that when we apply the constant we see it all, the wireframe acts in the same way, where it emits a constant amount of light no matter what hits it. So we always see the wireframe, but we don't see the color of the object until it has a light on it. If we make our light slightly bigger, you can see it creates a brilliant sort of dynamic shadow as it moves around. I really love how complex and amazing shapes you can get. I probably want to change it to a softer shadow than that. So Touchdesigner's real-time engine for this is mind-blowingly good, and it's the sort of thing that you can play about with and create super realistic real-time lighting scenes just with the introduction of the correct use of materials, animations and geometry build-ups. So that we'll end this stream here for now, and when we come back we'll look at SOPs and the use of 3D shapes more specifically, less so than the real-time sort of geometry world space, which this one more covered. So I'm going to save.